Um, One particularly useful functor that um, you might find helpful if you're implementing a hash table is the hash functor object. The hash is a templatized object. It's inside the functional header, and it provides standard hash t, templatized object. And we can set t to be just about anything, and that will create an object for us of this type that provides a functor that creates a hash index from that object. T can be specialized for any primitive type like integer, double character, and for a lot of the types within the standard library like string. So we can just declare this object and use it to produce hash values. So here's an example. I include functional, and then I declare that I want a functor that called hash that operates on string type, and then I'm just calling this HSTR for short. And now to produce some hash values, I just use its function call operator, passing in a string. So here I pass HSTR, the string hello world, and this is the first thing that's going to get printed, and you'll see that this is the hash index it produces, a really big random number. Who knows how it came up with that? And then I give it a slightly different string. I just changed this last character to a question mark, and it produces this different value. Okay, and then if I wanted to use this in the context of my hash table, I would just need to modulo this by the size of my table, and that would give me a pretty good index. And since even two strings that are almost the same are producing different values, I have a lot of confidence, or at least I hope they're gonna hash into different indices. Here's another example. Let's say I want a hash table for pointers. Then I would say that what I'm hashing are integer pointers. And then I'm calling this functor hptr. And then what I do is I just declare a variable x, and then I'm going to pass its address into this functor object and have it calculate a hash value for me. And then I'm also going to print out the address of x so that we can compare them. Okay, and what we see here is that the hash value is this big number, and the address is this smaller number. So what's interesting here is that the address of my variable x actually doesn't use up the full 64 bits. The full 64 bits it could, but the hash value does. So the hash function is like taking information out of this address and expanding it to fill up the full 64-bit value. And that's good because it means if I have two addresses that are close to each other, this hashing function is probably going to do a good job of giving them really different values and ensuring they go to different locations in my hash table. And in fact, I could put any kind of pointer here, and this hash function would work. And sorry, my comment is wrong. There should be an integer pointer hash function on this slide. Okay, so if you need a hash function on a common type, you can use standard hash templatized to that type. T can be specialized for all primitive types and pointers and many of the types in namespace standard. And if you want to read more about it, you could just do a quick Google search, or you could follow this link to cppreference.com.